Hello again, folks. It is time for your daily dose of Dorfler. I told you I was going to make that saying stick today. Anyway, we are here to work through our lab that unfortunately we cannot do this year because of extenuating circumstances, if you will. We're going to be doing the mole ratios, the copper and silver nitrate lab. And this is actually a really awesome lab. It ties in everything we've covered pretty much the entire chapter pretty well. And it also is neat to see how this reaction actually takes place, what happens throughout the process. And so this lab does take a little bit of time. However, I won't be showing you every single second of this lab. Once I kind of get it set up and the data marked down, which is what you're going to do, you're going to do this along with me, is we are going to essentially pause the video, and then I'll kind of do a few bits and pieces as we go through. And then before significant steps of the lab, I'll get the video back in, and you'll kind of work along with me as I do this, okay? So real quick, what you want to do is read the background first, okay? Gives you excellent information. I have said that the entire time. Read over the experiment overview on that first page. Okay. In fact, I'm going to get rid of that. All right. So we're not doing pre-lab questions this time. If you want to look at them, great. But I'm not going to make you turn them in this time. All right. Just because we're kind of on a tight schedule, and I'm not going to stress you out with that. So what you want to do before you start any lab, make sure you have the proper safety equipment, know what materials you're going to use, make sure you have all the materials ready, and where they're supposed to be. All right. Some of the things you need to know about this particular lab is I will be using nitric acid. That's a big acid right there. Okay. That is, when I say big acid, that means it is one of the big, strong acids that can be pretty damaging if you don't take the proper precautions. So that's why I got the goggles. That's why I got the gloves on as well today. Also, we'll be using silver nitrate. All right. Silver nitrate could possibly be toxic by ingestion. It can stain clothing. So you don't really ever want to do this lab or any other labs if you have really nice clothing, unless you have some sort of apron or lab coat to go over it. Your clothes, okay? Anyway, what we're going to do is we're going to go through the first series of steps. Like I imagine us for the initial part, we are going to get through probably about number 10. And then we are going to have to kind of wait about 15 minutes. All right. So that's when I'll pause the video here and there and show you some what's happening with the reaction. And then after that time's up, then we'll kind of move on from there. But this is a 2-day lab. And really the second day isn't that long. It's just we have to let the material that forms dry overnight. So tomorrow or the next video that you'll see regarding this lab, you will have to do some final data writing, I guess is what I want to say, into your lab handout. Okay. So it'll be over a day or so. But anyway, let's begin, okay? I don't do too many of these labs on video, so that's why I'm a little different than what I normally do on videos. Anyway, let's start off with number 1. I don't want to sit down doing this. So, goggles on. Ready. All right. We are going to obtain a clean and dry 50 ml beaker, okay? 50 ml beaker, right there. All right, we are then going to turn our balance on. There it is. If I can get my camera to stay. All right. So for step 1, it says carefully we need to obtain a clean and dry 50 ml beaker. 0 or tear. Okay, so on these little scales, this is T button over on the far right. Okay, now, as you see, come along with me. It reads 0. Okay. Next, we are going to Sorry about the camera work. Again, I'm doing this by myself. We are going to add approximately 1.4 to 1.6 grams of silver nitrate crystals to the beaker. We are going to, again, follow the cautions that they say by using a scupula or spatula, whatever you want to call it, to help transfer the silver nitrate crystals. Okay. So once I get this in there, I will then tell you what to document in your data table on the back side of the packet. Okay. So, like any other substance, you always put the lid back on tight when you're not in use. All right, so if you can read this, it says 1.5. I mean, I couldn't have split the difference any better than that. Okay, so, and I didn't spill anything, so that's good. So on the back table here, okay, on the back table, it says mass of silver nitrate. On this blank, you need to put 1.50 grams. Okay, this is what you should write. 1.50 grams. Okay, just like that. Moving on to step 2. Again, well, that's what we do, measure and record. Okay. Step 3, we are to fill the beaker that we just had our silver nitrate solution in to 30 milliliters. And I'm using deionized water. So we are going to fill it up to the 30 mark. I'm using this rinse bottle because it allows me to keep really good control over the amount of water that's going in there. And I can also begin to use the pressure from the bottle to help stir things up. Because after we get this filled, we want to make sure that we stir the solution so that everything is dissolved. All right, so there we go. And I'm going to go ahead and just give this a nice stir. It can take a little bit of time to get all this silver nitrate dissolved. It's a lot easier if you use water that's kind of been set out for room temperature than it would be just get it directly from the tap. And plus, with the type of water that we're using, we make in-house, as they say, and there's going to be little to no contaminants in the water. All right, so there we have it. I want you to take note of just how, you can't see that, of just how clear that solution is. Because you're going to notice a change that once we get this reaction complete, there's going to be a difference in what we're holding here. Okay, so I've got everything dissolved in there. Next, we are going to go ahead and cut a 25 centimeter piece of copper wire and loosely coil it into the shape as shown in figure 1. Well, I've already done that. Here is my loosely coiled copper wire there. I want you to take, again, a note of the appearance of this wire. Okay, it's kind of shiny. I don't know if I can help out, but it's got a little bit of a dullness to it. Okay, it's been exposed to air for quite a while, so it's not as shiny. There's a little bit of what they call patina on there, but you're going to notice again once the reaction has taken place a difference in the appearance of this as well. All right, so our next step is to find the initial mass of the copper wire to the nearest hundredth of a gram and record it in the data table. Okay, so I'm going to place it there. And on our data table, where it says mass of copper wire, okay, we're going to put 1.90 grams. Okay, just like that, 1.90 grams. So again, as part of your lab, it says in this part right here to make your observations, reactions with copper and silver nitrate. Okay, so that gets us through step 5. move this here. Step 6 says use a wooden splint to suspend the copper wire in the silver nitrate solution. Okay, so I'll bring this over here. The copper wire should not be touching the bottom or sides. So I cheated a little bit and kind of did a dry run of this. So again, I've got it suspended just like this on a wooden splint. Okay. And I tried to get as much of the copper wire as I could to be submerged in there. Okay. And then we're going to carefully add 3 drops of 3 molar nitric acid to the beaker. Okay. And it comes in this little squirt bottle. And the key thing is I do not want to jostle or touch the desk or the container as much as possible for the next 15 minutes because it is very fragile. And I'm not even going to stir the solution. So let's go ahead. 1, 2, 3. All right. So according to my time, it is 12:31. So in about 15 minutes or almost quarter till 1 o'clock, we'll be able to come and take a look at this. But I can already see just from the start, what's happening here. Let's see if I can't zoom in a little bit. Look at the copper wire now. It's only been not even a minute, and we're already starting to see what looks to be like fuzz or fur growing on the copper wire that was submerged. Well, that is not fuzz or fur. That is silver that is being replaced or taken away out of the solution and being placed onto the copper wire. So it's going to be pretty interesting to see over the next 15 minutes or so just how fluffy we can make this copper wire. I want to pause the video for now, and then I'll touch base with you in a little bit. All right, I'm just checking back in. It's been just over 5 minutes. And let's see what we've got here. You notice anything different about the solution there, the color? And look how furry our copper's gotten. So yeah, you might want to be jotting these down in your data table so you can have that complete. I'm going to, again, pause the video, and I'll be back here in about another 5 minutes. All right, we're about the 10-minute mark or so, and not a whole lot has changed since about 5 minutes ago, with the exception of the water being a little bluer, a little darker, and just a little bit more of fur forming, if you will, silver fur forming happening. I don't know how much is going to happen from here on out. As you can see here, down here, I already have some silver being, what we say, lost during the process. And so that's when you start to ask yourself, what is the best process to extract silver in a situation like this? Is this the best way, or could we come up with other ways, or could we use the same way, just come up with a better way to catch the product that is lost, quote unquote, okay, to where we can have minimal, if any, loss? So those are things we have to think about when we do experimentations. Is it the right one? And if it is the best way, can we make it better, quicker, so on and so forth? Okay. So next time I check in with you, we'll be getting ready to move on to the second half of the procedure. So we will see you there. Stay tuned. All right, we are back, folks. It's been 15 minutes since we started this reaction. I'm just kind of giving you a swing of the camera here. Just you can see the water is real, or the solution is really blue, meaning that the copper from the copper wire has been replaced with the silver. So those copper ions have actually been moved over into the liquid, and that's why you're getting this blue color, because copper in a solution typically turns a solution blue. All right, so now comes the nerve-wracking steps here. So we are on step 12, and while holding the wire with the wooden splint, we have to place the copper wire above a clean 100 ml beaker. Anyway, but before we get to that, while that was occurring, on step 10, it says I had to find a 100 ml beaker and weigh it. And so on the back, it says massive empty 100 ml beaker. It was 57.24 grams. Okay, so you'll need to know that number, especially for tomorrow. Anyway, back to step 12. Okay, so I want to be really careful with this because it is very fragile. It's not on there like it's with glue, okay? It's just hanging on barely. So hopefully I can get my shaky hands to gently lift this up so I can save as much of the product as possible. And there we go. Perfect. So now what I'm going to do is I'm going to use the same water I used to fill this beaker up to rinse off the silver. Okay. It should come off pretty easily. Again, you don't want to be too crazy with the sprayer because it does come off. It's almost like sand, wet sand at this point. So it can take a little bit of water and it can be a little frustrating at times because it just wants to glob on every once in a while. There we go. And see, since I made my rings pretty closely wound together, it doesn't want to come off as easily if you had it wider. Okay, I think, make sure I get everything down in there. And it says to use about 40 milliliters, and I used about 40 milliliters. It's like they've done this or something. Okay, so what I'm going to do now is I'm going to try to get as much of that the silver off as possible. And so all the silver appears to be gone. Okay, see that? Now what we need to do, we're going to go place it in acetone. Okay, now the acetone is being kept over in the fume hood over there because acetone is a highly volatile substance, and so you want to keep it in an area to where it has pretty decent ventilation. And so all I'm going to do, maybe, is place copper wire in here for a few seconds, shake it a few times, okay? And then I'm just going to let it air dry over at our station, okay? I'll let it air dry over at our station, and then I'm going to show you the difference in the appearance that the copper wire looks like. So after about 2-3 minutes, we'll take a look at that, okay? Meanwhile, while that is drying, we are going to go ahead and examine this beaker. Okay, let's put it back down here. Okay, so all that stuff down there, if you can see it better, I'm trying to get my hands to where you can see it better. All the stuff down there is silver, okay? But right now it's not in the best situation. So we're on step 16. We're going to come back and do step 15 here in just a second. So what we need to do is we need to try to what's called decant the liquid here. And I'm going to go back to my stirring rod because it's got this nice little rubber part here. And I'm going to try and dump this out. This is my waste container here. So I'm going to try to dump this water out without losing any of the product as much as possible. And, again, this is one of those situations, steps in the process that could be changed, if we found a better way to do this. And I have thought about some other ways too, but I want you to think about what other ways could be a better fit for this process of separating the liquid, the rinse liquid, and the product. Okay, so now, according to the instructions, I got to spray this down as much as possible. Okay, about 5 to 10 mils. We just want to rinse it so we can get as much of the other solution out of here so we can have just pretty much dry product. And see, I'm losing some, which again, in the end, it was going to cause my my theoretical and my actual yield to be different. And it says to do it one last time here, so we'll do it one last time. Okay, not a whole lot of water this time. And then we're just going to, again, pour it back. That should be nice and rinsed. So what we're going to do now is we're going to place this container that has the silver on the bottom. We're going to go put that in the fume hood and let that air dry as much as possible over the night. So it may be longer than 24 hours. It just depends. Okay, you want to make sure you get all the water out of there because you don't want any of the water interfering with your final mass that you get. Okay, and then once this whole thing's done, this is going to go in my retirement fund, remember? All right, so I'm just going to place this over here under the fume hood. Okay. And then I'm going to go back to step 15. Okay, step 15, I'm going to push this wastewater off to the side. Step 15 says, measure and record the final mass of the copper wire and note the appearance. Okay, so while this is booting up, I'm going to try to see if you can't see the difference in appearance. Okay, if you look up where this area is, where my fingers are, that was the initial color. Okay, that's what it looked like before it went into the reaction. Now look at it now. How would you describe the difference in that? Okay, it's pretty significant in person. I know it might not be as easy through your computer screens, but you should be able to tell the difference from before and after. Okay, all right. So let's weigh. Okay, so mass of leftover copper wire, which is directly below the 100 ml beaker. That is 1.73 grams. Okay, so I'm just going to give you a hint. Okay, so mass of copper wire, 1.73 grams. Whenever you are doing your calculations, say especially for number 1 and number 2 on the post lab, you need to be using the difference between the initial and final masses, because the difference that you find is what you're actually going to be using for your calculations. So I'm going to help you out here. Okay, so if we look at nitrate, okay, I'm going to move this over here. If we look at nitrate, so AgNO3, silver nitrate, we start off with 150 grams. 1.50 grams. All right. We won't know how much, actually, we don't have to worry about that. We won't know how much silver was produced until tomorrow when we weigh it here. Okay. So, come on. There we go. What we do need to do is look at copper. Okay, we start off with 1.90 grams. The leftover copper was 1.73 grams. And so this results in 0.17 grams of copper that was used. Okay, so that 0.17 grams of copper is what we're going to be using for our calculations for when we do discuss or have to calculate for copper, okay? So number 1 says, calculate the mass and moles of copper wire that reacted in this experiment, okay? So that's why we have the 0.17 grams. That's how much, this is not easy, that's how much copper reacted in this experiment, okay? So one of the last few things we need to do today is, on my end, I need to dispose of the waste solutions. I need to dispose of the initial solution that had the nitric acid in there, which is why I've got this decanter. So I'll be dealing with that. Tomorrow, we will come back and measure the mass of the dried out silver, record that data, and then you will be off and running on your post lab. All right, folks. So thanks for hanging in there. Again, you'll be seeing this a little bit later in the week because you need the last section of chapter 3 to fully understand this lab. So with that being said, I will see you all later. Bye-bye.